Hi, have you heard about AI lately? Maybe like a little bit? Cool. So reading all the breathless hype around AI, it's really easy to lose sight of the fact that it isn't magic pixie dust. You just sprinkle on top of a problem and solution pops out. Does this work? Did that do the thing? This doesn't work either. How about that? Hey, okay, I'm gonna be double fisting the laptops. Here's, here's how we're gonna do this. In fact, the idea that an average team would think about adding AI to a product was nonsense like 2 years ago. And once upon a time, all machine learning was very handcrafted, like artisanal. Every application required that a bunch of PhDs with deep domain expertise build an algorithm that was single purpose and one purpose only, and it wouldn't generalize. The number of people who could do this was vanishingly small. And when I think about what's happened in the last 2 years, what strikes me is how many more people are using far fewer tools to add intelligence to their products. And actually, we've seen two revolutions in the space happen in the last decade. Right? The first was the advent of deep learning. Right? My better half, my wife, happens to be a machine learning engineer, and she spent a good chunk of her career working on algorithms for medical computer vision. I remember when she came home from a conference and told me how every benchmark in the field was being absolutely destroyed by this single technique, deep learning. Tens of % of improvement using a generalized technique where people were normally happy to squeeze out like 1 to 2% like improvement would have been like, whoa, a really high water mark for like, submitting a paper to a conference. So machine learning after deep learning is still difficult, but now there's only one technique and many more people who know how to wield it. Many more sources of information about how to use that one technique to build things, how to get other people up to speed, right? Like lots more blog posts and things to read and learn. And the second revolution was the broad availability of large language models. Right now, you needed no particular skills to use machine learning. You take a generalized off-the-shelf model and you prompt it in plain English and magic happens. So basically, any school child has like all the tools they need for talking to this thing. So now we have one tool that seems to be pretty great at a lot of tasks, and you don't really even need to write code to use it. So in reality, this picture tells me that we've just moved the problem domain around. It's ridiculously easy to grab an API key and come up with a naive prompt and build a little demo that works some of the time. And that's exactly what's driving a lot of this hype, because 10 minutes after you get your API key, you have something you can screenshot and tweet and share and go ask a venture capitalist to fund. So yeah, but demos are not products. It's really easy to cherry pick results that look amazing, except that all of that falls apart as soon as you have a product that people use, right? You have to make it robust. You have to make it deliver value to a wide variety of people from different backgrounds. You have to come up with a notion of what constitutes good, right, versus bad. And you have to come up with a way to measure your thing to know if the effort you're putting in to improve it is taking you in the right direction. And if you're trying to add intelligence to an existing product, then you're probably going to want to change how that product works in order to make the AI part succeed. When televisions were first invented, the dominant form of broadcast entertainment was the radio drama, right? The first television shows were just radio dramas with a camera. Like they just stick a camera in front of the people that were there with like all these props that made noises, like they pop a balloon and it's like bang, like a gunshot, and that's when the murder happened or whatever. They didn't yet know the language of this new medium. They didn't know how to make television. They knew how to make radio, and they just stuck a camera in front of it. And you probably don't want to make things like that. And that's kind of where we are today with AI. So, hi, my name is Idan. Today I want to talk a little bit about the things that go into making products. I lead a prototyping team at GitHub called GitHub Next. You may have heard of us. We have done things like Copilot, which you may have used. A little over 2 years ago, when we were first starting work on the thing that eventually became Copilot, there was almost no prior art. We had to figure everything out. How it should look, and how it should work, and how we test and measure so that we could iterate. And fast forward to like last week, there was a big GitHub marketing launch thing, Copilot X, whatever. It's really 6 different things in like a trench coat. It's no longer one modality. It's no longer just in the editor, and it's no longer just about writing code. It could be about writing tests or explaining your PRs or putting a more helpful interface on top of your documentation. But the bottom line remains the same, and that is that every product needs a mountain of work to earn its launch. And it's not the same mountain that we might be used to climbing. The mountain is often work that has nothing at all to do with AI. So prototypes are your base camp. Let's talk about this mountain. The rest of this talk is all about this mountain of work and what's hiding inside it, and what it takes to go from that base camp to the summit. So let's start with the user experience of AI. If I showed you this text 30 years ago, this blue underlined text, it had no particular meaning. But by now, it has a fairly universal meaning, right? I can show this text to anybody and be like, yep, that's a hyperlink. I can go where it links by clicking or tapping on it. And at some point in the late 90s or early aughts, that meaning became general knowledge. It became a basic mechanism in the sense of like a pulley or a screw or a lever, these fundamental mechanical things that we've discovered out of which larger machines are composed. Ultimately, these basic mechanisms afford you some mechanical advantage. You're doing the same work, but that work is easier. So the hyperlink was one of the first simple machines discovered in the internet age, right? Instead of manually needing to like take an address and type it, I could just click on the thing and go there. And every time we find a new technological medium, we discover new basic mechanisms for it. Even today, like as soon as the smartphone was invented, when they were first invented, refreshing content was like I had to find the refresh button and tap it, which was fine. I mean, I have a button and I tap it, but it's taking up screen real estate. It wasn't until 2008 when Tweety, the original Twitter app that later got bought by Twitter and turned into the Twitter app, first implemented pull to refresh. And as soon as it happened, that was very clearly like, oh, that's real television. That's not radio dramas for iPhones. Because it banked on everybody's implicit understanding that new content is further up, right? And it didn't take long for like all the smartphone platforms to adopt this mechanism as a native gesture. So now we have AI, and there will definitely be new basic mechanisms. And I count 3 so far that we've sort of come across. There is ghost text for any kind of creative activity. And I would argue that ghost text is designed for optionality, giving me a lot of different options. There is brushes, which are designed for editing. And I'd say that their purpose is transformation. I want to take something and I want to apply some kind of transformation to it. And then there's chat. Everybody knows and loves chat now. It's really, the Zoolander meme. Have you heard about chat? So hot right now. I would say that chat is about exploration and planning, right? Designing for iteration and that sort of modality of interaction. 2 years ago, chat and brushes didn't exist, and we were focused on the basic problem of how to present code suggestions to users. And ghost text wasn't actually the first thing that we tried. The first thing that we tried was generating a list of potential suggestions to accept. And this, by the way, little known fact, if you like Control-Enter, you will get this interface in Copilot today. It's still there, even though almost nobody uses it, and I get why, because it's not as helpful. It surfaces a lot of options, and it's particularly helpful in contexts where you don't quite know how to do a thing, because each suggestion might show you a different way to do that thing. Or maybe like you'll see like, oh, I want like a little bit of that part, but then I also want to follow it up with like that approach from suggestion number 3. But on the flip side, you're incurring a lot more compute cost to eagerly generate suggestions number 2 through 10, which most people never go to, just like the second page of Google. And it's modal, right? To use this, you have to stop typing, invoke Copilot, wait, and then browse the options, and then it's a tax on your executive function to like choose among them, like, which one of these do I want, which is a higher executive function tax than yes or no, right? And if you don't like any of the options, then you have to like back out, alter your code, and repeat this process. So you pay this tax over and over again. One of the other prototypes that ended up on the cutting room floor was like a Tinder-style accept or reject, right? And this definitely had the benefit of lowering costs, like actual dollar costs, because we're not generating 10 things at once. We're running inference to generate just one. But it was still unacceptably modal. Like you needed to stop the activity of coding, trigger Copilot, and then take another positive action to move forward. And that's a lot of disruption for a developer that's in the flow of creation. And we really didn't want to sacrifice that. And so we ended up with ghost text, right? We didn't invent this mechanism. I'm pretty sure that there were snippets of ghost text in Gmail by that point. But they were like a few words at most, like, hi, nice to meet you, or like, thanks and keep in touch, or something of that sort of order. And that was definitely the right call, ghost text for Copilot, for a few reasons. First, it's ignorable, which sounds bad, especially for like a product. It's like, I want my product to be ignorable. No, it's ignorable, and that's good, and it's modeless. I'm not switching into a different mode while working with it. You can wait for them to appear, or you can keep typing. And if you do wait for them to appear, you can decide if you like or don't like them and keep typing. There's no like additional action that's forced on you as somebody who's like in the flow of typing. And if you kind of like the suggestion, but maybe like you think that if you give it a little bit more context, you're likely to get a better one, then you can just keep typing a couple more characters and get a new suggestion right there, again, without having to toggle back and forth between these modes. And finally, being modeless reduces the friction to accept and edit, meaning if I like part of a suggestion, or like, it's like, okay, I see where you're going with this. I don't want exactly that, but you've shown me the way. And now I want to take that and adapt it for my purposes. Then I can do that very easily with ghost text. I accept, and I can immediately, I'm still there with my cursor in the editor right there at the end of the suggestion. I can go back and edit it. So it's not demanding too much commitment from me as a user. There's one very key downside to ghost text, and that it's ghosted. It's ghost text, whatever. Without the assistance of syntax highlighting, it's harder for me to read the suggestion. I mean, I've gotten accustomed to all the code that I read being syntax highlighted, and I'm sure everybody else has as well. The problem is that you can't control for users' themes. Like some psychopath out there has like some wild theme with like crazy colors, and if you reduce it to 50% opacity, then some of those colors are going to be illegible. And so we can't ghost text syntax highlighted things. So that sucks, but it's a reasonable trade-off for all these other good qualities that I highlighted. But most critically, ghost text is a kind of hedge against suggestion quality not being where we want it to be. Like, we might not be far off from a future where most suggestions are bang on. But today, it's not yet the case. Like, we need to design for the failure mode where we are today, where the AI isn't perfect and not all the suggestions are exactly what I want. Like, we still haven't developed, like, telepathy, brain link, whatever, like Elon Musk is supposedly cooking up, I don't know. Suggestions can be wrong, they can be distracting. I might not want them right now. If you don't make your UX forgiving, then on some level, you're betting in your ability to get perfect results out of the model. And if you don't have that ability, you need to design against it. And sometimes it's fine, but for lots of applications, you can't assume that level of reliability and quality. Something interesting that I've noticed about the UX of Ghost Text, I don't really have an answer for this, it's really just something I'd like to note, is that it's slowly changing the way that I type while coding. Like over time, I've gotten a sense for when it's likely to deliver a good suggestion and when not. Like if I'm working in a file where I've already supplied a lot of context and I'm doing something that feels relatively boilerplatey or straightforward, then I'll slow down a beat. I'll give the model a second just to like flash me a suggestion because maybe it'll home run it for me. And when I'm not, like if I'm typing in an empty file or I'm doing something not obvious or I'm working on like basic architecture, when there isn't enough information yet for the model to make like a sanguine guess about where I'm going, then I don't slow down. So something like, there's something in there about the feel of like a gas and a brakes in the car that you acquire over time through driving. There's something in there in the user experience of Ghost Text, and I think it's really interesting that it's changing literally how I physically interact with the machine. And I wonder what more is out there like that. Wait, I'm going back. I forgot one point, which is thinking about designing not for the first use, but for the 100th or 1,000th time, right? Like if you're using Copilot, yeah, on day 1, you're like, okay, cool. And by day like 30, you're like, I've seen this now literally a billion times while coding. So in addition to designing for hedging against failures of the model, designing for the 100th, 1,000th, millionth time that users are seeing a thing, and what is their experience going to be in that steady state, not their first impression, which we often talk about, like what are the first impressions of users, how do we make sure that they don't bounce, right? But we shouldn't also neglect the other side of the spectrum, which is like, cool, it was new for 5 minutes, and then you have the rest of your life to like live with this thing. Okay. I have a little bit less to say about the other 2 basic mechanics because they're quite a bit younger. Brushes was an experiment by one of my teammates, the very talented Amelia Wattenberger. She is Wattenberger on Twitter, and you should look her up because everything she does is dope. The UX of being able to paint arbitrary transformations onto code is very powerful and super familiar to anybody who's ever selected some text and made it bold, right? Except here you can select some text and be like, add comments or fix bugs or more subtle instructions like make this more accessible, right? You can actually sort of prime the model with these very woolly instructions and actually get useful results out of it. So if Ghost Text prioritizes the needs of creation, Brushes is all about transformations. And as much as we talk about writing code, maintenance is a much bigger part of the job. Like, I write code once, but then I maintain it forever. So if we're not designing interaction models for that, then we aren't designing defensively for like the reality of our jobs. If I had to make a guess, I'd say that we're going to see more interaction models around direct manipulation of code. Maybe things like Brushes will be a jumping off point for supplying context to other patterns like chat. Like I select a thing and then I apply some transformation, but then it shows up in my chat sidebar and I can iterate on it before like, like now back to the studio, Fred, like, and it comes back to my editor. Speaking of chat, I'd argue that the core of chat is iteration. You can ask the model for something, and if it isn't quite right, you can refine. And that refinement seems like defensive design, right? Like I'm guarding against, like what if the model like didn't quite hear me right, and I just need to sort of like, can I say it again? Can I say it louder? On one hand, there's a ton of flexibility, right? Like you don't need to figure out how to elicit desires from users because they're just going to tell you what they want. They're literally going to type it into the box, and that's fantastic. But on the flip side, you might be dumping part of the prompt crafting problem onto the user and sort of abdicating your responsibility as a maker of product to help them succeed. That said, GPT-3.5 was already pretty adept at interpreting requests, and GPT-4 is clearly better in our experience. So maybe this isn't a problem anymore, or maybe it's not going to be a meaningful problem in the future. So I think the most interesting aspect about chat is the statefulness of it, the persistence of context. But right now, every conversation is an island. What happens in the future when every conversation might be aware of all previous conversations? Obviously, that's bounded by like what's the size of your prompt window, but maybe there are other tricks that we can bring to bear on that. If I'm building chat into my product, I want to think maybe at this point about how I'm making that history useful to my users. So as basic mechanisms go, I like these three. I think they cover the core set of behaviors, and there's enough wiggle room to handle messy cases. You might use chat to plan an alteration or a brush to create a meaningful chunk of new code. So it's not like cut and dry, like use this for this and use that for that, use that for this other thing, and ne'er the twain shall meet. No, they actually do have some amount of like gray overlap zone between them. Some of your product considerations won't be about modality. They will be about latency. Everybody is excited for the power of the latest models. But with great power comes like very slow responses. So, and they stream in progressively, which doesn't work for some situations. Like not everything can you like have the like thing where it shows up. Also, the bigger, newer models are not always better. Very often, you have to make trade-offs of acceptable latency versus model power. Like, original Copilot does not, like we did not upgrade it to use GPT-4. The reason being that it's just too slow. Like, I can't get the full response. Like, if you imagine even just a session with chat, which is faster than GPT-4. If I waited for the full, like, streaming response to show up, say I buffered all of that, and I held it in memory. And then only when it was done would I show that suggestion to the user. I'd effectively be waiting, I don't know, like 5, 10 seconds, maybe depending on the length of the response that I'm expecting. That's unacceptable. I need to be able to show like suggestions to users in like 100 milliseconds or less, or I don't know, whatever. Part of the mountain of work is figuring out which models make sense to use where. It might be about latency, or it might be about cost, like actual dollar cost. Sometimes it's possible to invest more energy into prompt crafting and squeeze an acceptable level of results from a cheaper model. So there's like a ton of levers that you can try pulling around this. But the answer of like, which model should I use? Oh, the biggest and most powerful and most expensive one is not actually the correct answer in a lot of cases. Speaking about prompt crafting, I still haven't touched on the elephant in the room, which is prompts and how to craft them. One of the largest rabbit holes to get lost in are potential changes to your underlying product in order to elicit context from users that you can then use for prompt crafting. So like, if I show you a to-do list, probably the point is not to give you a to-do list. There's a million to-do list things out there, and they're all fine. You know, I have text with like checkboxes next to them. But if you check a thing off, you've just told me about a semantically meaningful event, right? I can use that to trigger summarization of recent work and create commits on your behalf. I can prime that summarization with a description of the to-do, or I might want to use that to instruct the model to find the changes in your code base that are relevant to that task, because maybe like you did a few different things, but then you remembered, oh wait, I took care of this one and I check it off, and then I want to use that to-do description to go find the changes that belong in the next commit or something like that. But this basically grows your solution space to infinity. Like changing your product is a bottomless rabbit hole of options. So yeah, part of the mountain of work is figuring out like, what's the right trade-off? How much do I think about changing the product? It's hard, and there's no really clear answers there. So I'm just telling you what's hard, not giving you really any useful solutions. Sometimes I like to joke that GitHub Next is the prompt whisperer team. That's what we do. We whisper in the ear of the Oracle. Oh, wise Oracle, please tell us which set of characters comes next. It's a lot of trial and error, right? I can't overemphasize this because the models are famously black boxes, right? Like we don't know. If any of you are cryptography nerds, holler, then it's kind of like a chosen plain text attack on the models. You're just constantly like throwing things at it and seeing what comes out, and then iterating on like what you're throwing at the thing. And whatever anecdotal thing you try when you're designing your prompts, you don't know whether or not it works just from your experience, because whatever you're seeing is at best anecdotal. So you need to do measurement at scale, and I'll talk about that later. I want to invent maybe a distinction that people like use prompt engineering and prompt crafting interchangeably, and I kind of believe that they might actually be two different things, or that they deserve to be two different things. Prompt engineering is all of the work needed to gather context and process it and get it ready. And prompt crafting is more formulation, like how am I structuring the information that I have on hand into my prompt so that I hand it to the model. Maybe somebody else has already coined this and I'm late to this party, whatever. In naive olden days, you'd spend some time sourcing context and then you just paste it wholesale into the prompt and ship it, right? And hopefully it's good enough. But now we're talking about all these fancier architectures for the entire pipeline, and you have heuristics at multiple stages. So I'm going to talk mostly about prompt engineering because prompt crafting is like a topic for an entire talk and 15 different papers on arXiv. So yeah. Models only know how to say what comes next. Asterisk, this isn't strictly true anymore, but generally speaking, that's what models are, right? It's like you show it something and you're like, what comes next? They don't know how to say like, what goes in the middle? So in the work of making Copilot, like if the cursor is somewhere in the middle of the file, what if the code that's further down is actually really great context, right? What if the cursor is at the start of the file, like the whole file comes after? What context are you supplying then, right? Somebody once had a really nice t-shirt or sticker that was like, there's no magic in the cloud. There's no magic in this, it's just work. So like, what did we need to do? Well, like we needed to like do all this crazy work to hoist code around the file in semantically sound fashion. So we'd like AST the entire code base, build an abstract syntax tree, and then restructure the code such that if like, the cursor is here and there's a function reference above that's pointing to a function that's further down, I'm going to hoist that function up above so that it is included in the context, because that seems like it would be a useful bit of context. But I've just described to you like 3 months of work, right? How to do that like properly, correctly, not mess it up, check it, try it. If any of you have ever had the pleasure of using Tree Sitter, then you know exactly what I mean. Yes. Oh, did I not show the hoisting? Okay, well, sorry. You should have been seeing this slide now. Retrieval is another really interesting technique that I think doesn't get enough credit yet. People are talking about it, like, every once in a while I see an article on Hacker News about it. But the basics of this technique are that you use a separate model to generate embeddings, vectors in high dimensional like vector space, to classify different parts of your code. And then you can use that as a kind of similarity map. Like that indexing is very cheap. You can run it all of the time. Unlike fine-tuning, which is not cheap. And you have to do it if you want your model to always be aware of like latest developments and whatever. You need to do it basically all of the time. And particularly this has applications for things like, I would like to have Copilot that is very aware of our private code base, because the underlying models are only trained on on public sources, right? They don't know anything about whatever, idiosyncrasies your corporate code base has in it. So how do we make Copilot do a better job of giving responses for those situations that are like more in line with whatever your company standards are? If we leaned on fine-tuning, then we would need to train on your code base, and then train on it again next week, and then fine-tune some more the week after, and keep fine-tuning forever. And that kind of cost is just too high, and also everybody's in a knife fight for GPUs, so maybe we don't even have the capacity to pull that off. But doing the embeddings and then using that to find related code in order to more effectively put useful context in the prompt is way cheaper. I can do that all the time. And so the idea is basically like, say I'm editing some code to do with authentication. I could naively just include the rest of the code in the file in the prompt and send that off and be like, that's the context, that's what I got. But we found that we've gotten far better results from the models, and particularly the newer models that have bigger prompt windows, by saying, you know what, I'm going to include not necessarily the code that's in the same file, but I'm going to look for all other code that deals with authentication throughout the code base. And I'm going to use that as the prompt, along with specifically some amount of code from the file that I'm in, because you do need to anchor it somewhere. And that delivers actually fantastic results. And this technique is particularly relevant for the more powerful models. All that prompt budget is not useful unless it's actually used. Older models have less prompt budget, which forces a lot of acrobatics for like prompt crafting. Like we're sitting around trying to come up with techniques to like vote pieces of code off the island so that we have enough like room. So whichever model you use, retrieval can help. If you have a lot of context, then great. It helps you source more of that context. If you have only a little bit of context because you're using an older model, maybe it can help you like choose like more wisely the context that's going to give you the most bang for your buck and squeeze better results out of that cheaper model. And now for something completely different. This is prompt crafting. This is a higher level idea that I wanted to share on the prompt crafting side. Everybody is aware of like one-shot, few-shot for prompt crafting. This is few-shot. We experimented a little bit with using LLMs to help reduce toxicity in comments, right? Like how can we make everybody just a little bit more civil to each other on GitHub? Because everybody knows you roll up to like a project and maybe there's somebody who's just like, that's a terrible idea and you're bad and you should feel bad. But usually it includes a lot more expletives. So, we tried this. And one of the things that jumped out at me is that the best strategy that we had for prompting the model to reword how people wrote their comments, but in like a better and nicer and kinder way, was to reach for this notion of encode each trait, this high-level, hard-to-define thing like, yeah, I can be like, I don't want profanities in the code, but I also want comments to be intellectually curious. How do you instruct a computer to be intellectually curious? I can't, but what I can do is be like, okay, here's a formulation that isn't intellectually curious, and it's obvious to me because, I have so many years of my brain learning what that means. And here's some text that is intellectually curious. And I can do that over and over again for different traits, these high-level things. And so when you think about, like, I would like all these traits in the text that comes out, you can just think of examples of these different traits and feed it to the model. And that actually tends to work really well. So give fuzzy examples with this sort of strategy. And we found that it's delivered a lot of good results. It's looking like the state of the art is already more than just call and response to one model. Like, yeah, all of the hotness right now is all about GPT-4 and how good it is and how it works in all these different modalities. And it really is a strong general purpose model. But retrieval which I just talked about, is already a conversation with more than one model, right? I have an embedding model, and then I have the LLM. Copilot voice, which if you haven't seen is basically like Jarvis from Iron Man. It's like I'm like typing and I'm like, hey Copilot, like run my test for me, and also like suggest a function here, and also like open my terminal, and like I don't know, whatever. It works, and it's kind of cool. But that's using different models for different kinds of utterances. Like I have like heuristics and models figuring out, is this utterance about the terminal, or is it about I would like to open or hide some panel in the IDE, or is it about the code? Is it a question about the code, or am I instructing, am I dictating, like give me a function that looks up the weather in the zip code or whatever? So multiple models is already a technique that we're using, and I think that that's going to catch on like wildfire in the coming years, that there's only so much you can get out of one model that you're just like, what's the answer? That's the answer? Okay, that's it. Using multiple models raises the ceiling of like what's possible. And looking further out, we're also seeing a lot of value in multiple round trips to the model. So for example, I'll round trip to be like, what's a list of files that I would need in order to like implement this feature, right? I want to add a new like route to a new capability to my website or my web app or something like that. And I'll come back and be like, here's a list of files that I expect to see then. And then I'll take that and stuff it back in the prompt and send it back to the server and be like, okay, now what are the contents of these files? And I'll get that. And then I'll take all of that and I'll shove it back into the prompt and I'll be like, now write me tests that test all the content in these files. And it's fantastically expensive and slow from a computational perspective, but one day it won't be. And I think that that's sort of like that multiple round tripping sort of action is already demonstrating some interesting results. But yeah, bottom line is there's so little prior art, it's trivially easy to spend a ton of time and energy on this kind of trial and error. And so on to our third topic, which is measurement. How do we know that we're on the right track? How do we know if what we have is good, right? A huge, huge chunk of the mountain of work is setting up automated evaluation of your things. Like you change your prompt crafting, or you've changed which model you're using, or which models you're using. How do you know if it's performing? Well, you can deploy it and see, but you probably want some kind of smoke test before you throw your thing out there and end up with egg on your face if it's not working really well. So in our case, with Copilot, the way that we built smoke tests is we took code bases on GitHub that have a test suite already. We'd find functions that were tested, and we'd blank out the function bodies, ask Copilot to generate those function bodies, and then run the test suite, right? If we'd see like an uptick in failures of those test suites, then whatever we're doing is clearly like going in the wrong direction, as opposed to like if we see fewer failures, then clearly our strategy is paying off. And again, this was a mountain of work to do, having nothing to do with AI. We just needed to like sit there and write this whole like test harness just to have like some kind of early warning light about like, are the changes that we're making, are they okay? Or are they breaking something? And it's unglamorous, and it's boring, and it's absolutely necessary. Like any product, there's an explosion of metrics to track which ones matter, right? Again, drawing on our experience with Copilot, we know what suggestions are accepted or rejected, right? But even if they are accepted, it isn't binary. Like it's good when people accept a suggestion and then edit it. We want that behavior because we believe that that's correct. Like take the suggestion and adjust it to your needs. Like it's fantastic if every suggestion is just accepted wholesale and it works perfectly right off the bat, but we're not there yet. So we want to know about whether they've, the users are accepting suggestion, and if they're accepted, how much of the suggestion sticks around, right? So cool, I have a chart for acceptance rate, and I have another one tracking retention percentage. And I have that for like 30 seconds and 1 minute and 5 minutes and 10 minutes after the code is suggested and accepted or rejected or whatever. And then we roll out an update to the UX or the prompt crafting or whatever. And so now I have however many those charts are times 2, because I've got the old ones and the new ones, and I got to compare them. But wait, maybe these metrics are different by language. OK, hold on. Now I need all of those charts, but for like Python, Ruby, C, Go, Rust, whatever, like all these different things. And then we'll see if like acceptance rates. And that'll tell me maybe like, oh, is the model working better for that language or for that language? Or is it just that programmers in these languages just don't lean on Copilot as much or don't need it or need it in fewer situations? I don't know. And then you have practical considerations. So like maybe acceptance rates are about latency. Like where is your inference running? If your inference is running in US East or US West, and then you have developers in Asia or Europe, and you're seeing that their acceptance rates are lower, is it really because something is bad? Or is it just because it takes longer for suggestions to show up for them because the bits need to travel like across the globe to get there in time? What if like another 100 milliseconds of latency is why you're seeing like a drop off? So you can see this sort of like combinatoric explosion of charts. And part of the mountain of work is figuring out the right amount of charts to keep an eye on, because you can't keep an eye on like 100 charts at once. You can't possibly inform decision making with that amount of stuff coming at your face. And these charts encode a lot of things that are hard to tease apart. Like, is it about the language? Is it about the latency? Is it about this? So you don't want to drown yourself in metrics. This was true for products in general, not just for AI, which I guess is a theme for this talk. But AI products are maybe a little harder right now because there's less conventional wisdom. Like I can open Google right now and like type in, how do you measure a SaaS product, and get back like infinity blog posts that tell me everything I need to know about it. Not so much so for AI kind of things. I know I just said that metrics matter, and now I'm going to contradict myself. Metrics are just a proxy for value. At the end of the day, you need to figure out what value is for your situation. Like, I'm obviously drawing on our understanding of developers and what developers want in their editors while writing software. As much as that is a broad activity, it is also a relatively narrow activity compared to all of the other activities that exist out there that people conduct with computers. Figuring out what value is for your situation is the job. Keep figuring it out. It's a forever job. It's a steady state of workload forever. And you need to realize that you're signing yourself up for that workload forever. In fact, everything that I'm talking about today, sort of the underlying theme here is that when you want to do AI in your products, this is what you're signing yourself up for, whether you realize it or not. And so everybody who's made a demo in 5 minutes and thinks that they're halfway to a product, then I got bad news for you. There's a lot more work. There's a lot more mountain left to climb. And if you're not stopping to check whether or not you're delivering value, and that usually means, sorry, no technology, just talking to users and understanding what it is that they find valuable and understanding whether or not the AI that you've added to their lives is delivering value to them, then you're not doing your job. And you might be climbing the wrong mountain. Thank you.